Hello everyone, today we're going to be working on fundamental problem 6.8, and this problem is saying to determine the force in members LK, CD, and KC of the Pratt truss. State if the members are in tension or compression, and to also take that P1 is equal to 22 kilonewtons, P2 33 kilonewtons, and P3 44 kilonewtons. So the first thing that we're gonna want to do to start off this problem is we're gonna determine where we're gonna do that cut through the truss. And remember, something important to remember is you want that cut to go through the members that it's asking you to determine their forces. So it asked us to determine the force of LKCD and KC. So what I'm gonna do is I'm gonna do the cut right here where it passes LK, KC, and CD. So that's gonna be my cut right there, like to an angle, I guess you guys could say, right here. That's gonna be my cut right there. Now the next step is you wanna take a look at both of the sides of the trusses. So now we have a left side of the truss, and then we have a right side of a truss and a left side of a truss. Now we want to analyze both of them to see which one would be easier to work with. And you want to take into consideration how many reactions do you have to find before starting off using method of sections, and how many forces are you going to be dealing with. So if I were to look quickly on the left side, here we could see that our point A has a pin support, meaning that we're going to have two reactions, the vertical and horizontal reactions. So there we already have two unknowns, so would have to solve for those two unknowns. And then from there we have our two forces. From there, if we were to take a look at the right side, we know that we're dealing with one force, one known force, and then from there we have a roller at point G, meaning that we're just going to have one reaction, a vertical reaction. So taking a look at both sides, in my opinion, the right side would be easier since we would just have to deal with finding one reaction and with one force. So what I'm going to do the first, after determining the cut and then determining which side you're going to work with, the next step would be determining the value of our reaction. So since I'm only wanting to find the value of this one and these values do not matter, what am I going to do? I'm going to be taking the sum of the moments about point A. That way these two reactions don't create a moment, and that way I'd be only solving for that reaction at G. I'm going to assume that the reaction is going to be acting upwards, and we're going to call it G of Y. So if I were to, after doing the cut and determining which side I'm going to work with, the first step would be finding the value of G of Y. So counterclockwise positive, the sum of the moments about point A have to equal 0. So from there, we look up here. We know that a moment is equal to the force times the distance. So for our first force, we have a force of 22 kilonewtons, a distance of 2 meters, and since it's to the right of our point heading downwards, we know it's going to be creating that clockwise moment, so a negative moment. So negative moment with a force of 22 kilonewtons times 2 meters. From there, we could see that the rest of the forces are also on the right side of that point and going downwards. So we know that these three forces are going to be creating a negative moment. So then from there, the only thing that changes is just their force and their distance. For P2, we have a force of 33 kilonewtons and a distance of, we know that from here to here, there's a distance of 4 meters. So negative moment with a force of 33 kilonewtons times a distance of 4 meters. We said that the other force is also going to be negative, creating a negative moment with a force of 44 kilonewtons and a distance of 6 meters. So we're going to want to do 44 kilonewtons times 6 meters. And then from there, our last force would be our G sub y. I assume that it's going to be heading upwards. So that means that since it's upwards and to the right of the point, we know it's going to be creating that counterclockwise moment, meaning a positive moment with a force of, that's what we're trying to determine, and a distance of from here to here, 2, 4, 6, 8, 10, 12, with a distance of 12 meters. So positive moment, force, that's what we're trying to determine, times a distance of 12 meters. And we know that all of that has to equal 0. So from here, the only step you would have to do is just simply solve for g sub y. So if we simplify this down, we would get g sub y times 12 meters has to equal 440 kilonewton meters. From here, we would simply solve for g sub y, so we would end up getting that g sub y has a value of 36.7 kilonewtons. So with that, since we got a positive number, that means that we assumed correctly the direction of our reaction, so that means that it will be going upwards. So now that we know the value of our reaction, since we're going to be working with the right side of the truss, I'm simply just going to come back here and write out the value of it, 36.7. So now that we have that, our next step would be now drawing out the truss that we're going to be working with. So I already did that earlier on. This is kind of like how our truss would look like, the side that we're going to be dealing with. So what I'm going to do is I'm simply just going to move this to the side. Okay, so now essentially this is what we're looking at. We know that we have a reaction here, um, a reaction right here going upwards with a force of 36.7 kilonewtons. From there, we know that we have a force coming down at point D with a force of 44 kilonewtons. From there, our cut is going down right here. So from there, you would have to take a judgment and just be like, okay, I'm going to assume that they're either in tension or compression. If you want to assume that they're in tension, that means that they're going to be going away from the joint. And if they're in compression, that means they're going to be going towards that joint. I'm going to assume, I always like assuming that they're in tension. All of the joints and all the problems, I like assuming that they're in tension. And then later on, working through the problem, if I get a negative number, that means that they're going to be in compression. So I assume that all the bars and members are going to be in tension. That's why I drew the arrow going away from that joint. So then from there, you would simply just start using the method of sections to determine the force. So what I'm going to do is what I like doing is I like taking the sum of the moments about a point where two forces meet. That way we could solve for one of them. So I'm going to start off with taking the sum of the moments about let's see, FCD. So what I'm going to do is I'm going to be taking the sum of the moments about point K, since as you guys can see here at K, we have the force of the member LK and CK. So we know that both of those are not going to be creating a moment about this point right here. That means that we would be able to solve for the force of the member CD. So that's what we're going to do. So we're going to be taking the sum of the moments about point K. We know that it has to equal 0. So from there, we know that our force CD will be creating a moment. It is downwards from the point going to the left since we assume that it's in tension. So we know that it's going to be creating that clockwise moment, so a negative moment. And the force, that's what we're trying to determine. And then the distance, we know that from here to here, so this distance right here, if we go back to the image that they give us, we know that there is a distance of 3 meters. So we said negative moment, the force, that's what we're trying to determine, times the distance of 3 meters. From there, our two forces will be creating a moment. This one is going downwards to the right of that point. So we know that's going to be creating that clockwise moment as well. So a negative moment with a force of 44 kilonewtons and a distance of, as you guys could see here, our point 3 is right here. Our K is right here. So we know there's a distance of 2 meters. So again, negative moment with the force of 44 kilonewtons times the distance of 2 meters. And then from there, we have our reaction, which our reaction is going upwards. So this one is going to be creating a counterclockwise moment, meaning a positive moment with a force of 36.7 kilonewtons and a distance of, our K is right here. Our reaction is right here. So we have a total distance of 8 meters. So positive moment, force of 36.7 kilonewtons times the distance of 8 meters. We know that all of that has to equal 0. So from here, we would simply just solve for the force of the bar or member CD. So if we were to simplify this a bit, we would get negative force of CD times 3 meters that has to equal negative 205.6 kilonewton meters. So from here, we would solve for the force of the bar CD, and we would end up getting a value of 68.4 kilonewtons. Since we got a positive number, that means that we assumed correctly and that it will be in tension. So with that, we have determined the first member. So now we have determined this force right here. So now the second point where I'm going to be taking the sum of the moments is now at point C, because we know that if we were to take the sum of the moments about point C, we know that our force of our member CK will not be creating a moment there, and our force CD will also not be creating a moment. So we would be able to determine the value of our force, the force of our member LK. So the sum of the moments about point C has to also equal 0. So our force LK, it is on top of that point. It is going to the left because we assumed intention. So it's going to be creating that counterclockwise moment, meaning a positive moment, a force, that's what we're trying to determine, and a distance. Once again, we know that from here to here, there is a distance of 3 meters, which is given to us right here. So positive moment of a force times 3 meters. From there, We know that both of these will not be creating a moment. So from there, we just have our 44 kilonewtons and our 36.7 kilonewtons. So um, our point is right here. Our 44 kilonewtons is heading downwards. So that means it's going to be creating a clockwise moment, meaning a negative moment with a force of 4 kilonewtons. And we know that from here to here, there is a distance of 2 meters, as you guys could see right here. So negative moment of 44 kilonewtons times 2 meters. And then from there, we have our 36.7 kilonewtons. This is going to be creating that counterclockwise moment, so positive moment, force of 36.7 kilonewtons, and a distance of, once again, 8 meters. We know that all of that has to equal 0. So from here, if we simplify it down, we would get that the force of the member LK times 3 meters has to equal negative 205.36 kilonewtons. So from there, if we were to solve for the force of the member LK, we would end up getting a value of negative 68.5 kilonewtons. So here, as you guys can see, we got a negative number for our answer. So that means that it is actually going to be in compression and not in tension. So we could simply just state that. So now we're going to go back up to our figure that we drew. We found the force of the member LK, the force of the member CD. So the only one that we're missing is the force of our member CK. As we could see, this is a vertical force. And then from there, that's the only unknown force that we have. So simply what I'm going to do is I'm going to be taking the sum of the forces in the y direction, because for vertical forces, we just have 1, 2, 3, and only one of them is the unknown one. So we could do that to solve for its force. So the sum of the moments in the sum of the forces in the y direction have to also equal 0. I assume that the member CK is going to be in tension. So in this case, it is going downwards. So downwards, so a negative force of CK. From there, we have negative 44 kilonewtons and positive 36.7 kilonewtons. So negative 44 kilonewtons plus 36.7 kilonewtons. All of that has to equal 0. From here, we would simply just solve for the force of the member CK, giving us a value of negative 7.33 kilonewtons. Once again, we got a negative number, meaning that we assumed incorrectly. So you could simply just put right here that it is actually going to be in compression. And with that, we are done with the fundamental problem 6.8. So once again, to start a problem like this is first you want to determine where your cut is going to be. Usually you want that cut to go through all of those members that it's asking you to determine their forces, which is why we did our cut right here, or like that, because it crosses through the member LK, CK, and CD. From there, you want to analyze both sides of the Pratt truss, determine which one you're going to have to either deal with less forces or simply find less reactions. So we chose the right side since we would only have to find the value of one reaction. So to do that, what we did is we took the sum of the moments about point A. That way the reactions of our support at point A would not be creating a moment, giving us that opportunity to solve simply for our reaction G of Y. And then from there, we simply just use the method of sections to solve for the values of the forces of the members that they were asking us for. Thank you guys so much for watching this video. Please feel free to give this video a thumbs up if you guys found this helpful, and also feel free to subscribe to our channel if you guys would like to see more videos like this one.